Good day, everyone. And today, our topic would be sampling, data collection, and data analysis in quantitative research. Again, welcome, everyone. I'm your instructor, Dr. Lidor Labrague, and welcome to Critical Analysis and Nursing Scholarship. Now, before we dive into the concepts of sampling, I want to share with you a real event that had a major impact on the world of research and pooling. And this event is a good reminder of how critical proper sampling is. Now, back in 1936, a popular magazine called the Literary Digest decided to predict who would win in the US presidential election. And they conducted a massive poll. Millions of people were contacted, and it looked like a very large and impressive study. They predicted that Alfred Landon would win the presidency over Franklin D. Roosevelt. But what happened? They were completely wrong. Roosevelt won by landslide. Now you might probably ask, what went wrong? The answer is very simple. Their sampling method was flawed. They gathered names from telephone directories and automobile registration lists. But in 1936, only wealthier Americans could afford telephones and cars. That means their sample mostly included upper-class voters who tended to favor Landon. Now, they failed to include working-class and lower-income Americans who made up a big part of the voting population and largely supported Roosevelt. This mistake ruined the magazine's reputation, and it eventually closed down 2 years later. And this became one of the most famous examples of bad sampling in research history. Now, today's session, we're going to discuss sampling, why it is important, as well as data collection in quantitative research. For today's session, these are our learning objectives. First, we're going to learn about the sampling techniques. For selecting representative samples, we're going to differentiate what is probability and non-probability sampling. We're going to talk about what is sample size. And of course, we're going to talk about the different methods of collecting data in quantitative research. And last but not the least, we're going to talk about data analysis in quantitative research. Now, before we formally start our topic for today, let us first have a little review of the steps in the research process. We said the research process starts with selecting and defining a problem. And once the problem is clearly defined, the next step in the process is to translate this research problem into a well-defined research question. And once we have a research question, the next thing that we need to do is to formulate a working hypothesis. A literature review should be conducted to make sure that we're able to identify what are the gaps, what are known and unknown about the topic. And after the review of the literature, the next step in the process is preparing the research design. Based on our review of the literature and based on the research questions that we have formulated, what do you think is the most appropriate research design for our research? Once the research design is formulated, the next step in the process is prepare the sample design. Who will be included in our research? How many respondents should be included in our research? And that is exactly our session is all about for today. Okay, the first part of our session today, we're going to talk about the essential concept in research, which is sampling. Now, as nurses, you'll often encounter studies that use samples to draw a conclusion about the larger group. Now, let's going to break down the different terms that you might probably see often, and I'm going to give you a nursing example to make it easier for you to understand. Now, let's say I want to do a research or study about stress levels among nursing students. Now, the target population, this is the entire group I'm interested in. So for my study, which is about stress levels among nursing students, the target population is all nursing students in the country. I want to understand their stress. that is target population, and how it is different from accessible population. When we talk about accessible population, remember I cannot reach every nursing students in the country, right? So I'm going to focus on those I can reach. Maybe I'll choose nursing students in three nearby universities. That's my accessible population. So basically, it's a smaller group that I can realistically study. How about sample? Now, for those three universities, I still won't be able to study every student. So I'm going to select a group of 150 nursing students to participate. That group of 150 is my sample. In other words, the sample is a smaller portion of the population I'm going to study. And what is sampling? Sampling is the process of selecting representative units of a population for study and research investigation. Now, this refers to how I chose those 150 students. Do I randomly select them? Do I choose based on the year level? The method I use is called sampling method, and it's very important to choose the right one to avoid biases. So basically, when we talk about sampling, our goal here is to get a representative sample, meaning the people we study should reflect the larger group. If my sample is only made up of third-year students, can I say their stress levels represents all nursing students? Probably not. That's why sampling must be done carefully. Now that we've discussed sampling and population, let's talk about how we decide who gets included or excluded in a research study. Two important terms you need to know here. First, inclusion criteria, and the second one is exclusion criteria. Now again, we're going to use the same study about stress among nursing students. Now, when we talk about inclusion criteria, these are specific characteristics or conditions that make someone eligible to participate in your research. Now, these criteria help define who you are studying and ensure that you are selecting participants that are relevant to your research question. Now, for example, in a study on stress levels among nursing students, my inclusion criteria might be nursing students enrolled in their final year, nursing students who is 18 years and older, nursing students who are currently enrolled in full-time nursing program, and nursing students who are willing to participate and provide informed consent. Now, these criteria ensure that I am focusing in a group likely to experience high levels of academic and clinical stress. And these are final year nursing students. Now, when we talk about exclusion criteria, on the other hand, these are factors that would disqualify someone from participating even if they meet the inclusion criteria. Now, these are often referred to as the limitations. And these are very important because they can help control for extraneous variables or variables that might probably affect the outcomes of your research. Now, in the same study, I might exclude nursing students currently on academic leave. I might probably exclude students who are enrolled in part-time programs, and I might probably exclude students who might probably having pre-existing anxiety or stress-related challenges. Now the question might be, why exclude them? Because their stress levels may be influenced by factors outside the academic environment, which could likely affect the validity of your research result. Now that we understand the importance of sampling, let's talk about the two main types of sampling designs used in quantitative research. First, we have probability sampling. The second one is non-probability sampling. You might probably ask, how is probability sampling is different from non-probability sampling? When do we usually use the probability sampling over non-probability sampling? So when we talk about probability sampling, in this type of sampling design, every person in the population has a known and equal chance of being selected in the study. Now, in this type of sampling design, selection is basically based on chance. And this type of sampling design is considered as a more rigorous type of sampling method, and it uses random selection of samples. In research, this sampling design is considered the gold standard. Why? Because it reduces bias and helps ensure that the sample truly reflects the population. And since it's based on random selection, in here we can use statistics to generalize the findings from the sample to the whole population. For example, you want to study the stress levels of nursing students across country. You might probably use simple random, systematic random, stratified random, or most probably cluster or multi-stage random. And in here, you can probably select nursing students from different regions, year levels, or universities to ensure diversity and representativeness. Now, what is non-probability sampling? In non-probability sampling, not everyone has a chance of being selected. And in here, the sample is basically chosen based on judgment of the researcher. In other words, the inclusion of your samples in this type of sampling design is not random. And therefore, findings using this method is less generalizable and less representative. Let's say you want to study stress levels again among nursing students, but instead of randomly selecting them from various schools, you only ask those in your own university or even just your own school. Now, this type of sampling design is much easier and faster when compared to probability sampling, but the downside is that you cannot generalize the results to all nursing students because your sample may not represent the broader population. We're going to discuss in detail these different types of probability and non-probability sampling in the next few slides. Now, as a nurse researcher or consumers of research, we always pay attention to how the sample was selected. Why? Because the sampling method can impact how much trust you can place in the findings and whether those findings apply to your patients, to your setting, or even to your practice. Now that you know what probability sampling is, let's go deeper and talk about four main types of probability sampling that you might encounter in nursing research. Take note, each of these methods involves random selection, but they differ in how participants are chosen. The first type of probability sampling is simple random sampling. Now, this is the most basic form of probability sampling. In here, everyone in the population has an equal chance of being selected. Now, here's how it works. Just like what we discussed earlier, here you need to define your population and you need to set your inclusion and exclusion criteria and the number of participants that you wanted to include in your research or your sample size. And once you have a sample size, the next thing that you need to do in this type of sampling technique is to randomly select participants, just like a lottery draw or using a random number generator, or most probably a simple one by drawing names out of a hat. This is simple random sampling. One of the biggest strengths of simple random sampling is because this involves random selection, that means it minimizes selection bias. However, one of the limitations of simple random sampling is that it can be time consuming, especially if you are planning to include a large population. Now, for example, again, you want to study anxiety levels among third-year nursing students in your university. In here, by using a simple random sampling, you assign each student a number and randomly draw 50 names. That's it. Simple random sampling. On the slide right now, you will see an actual example of a research conducted which uses simple random sampling technique. Nata et al. In 2015 conducted a study on adherence to food self-care in patients with diabetes mellitus in Brazil. The population included is 8,709 patients with type 2 diabetes. And here, the sampling technique utilized was simple random sampling, and they included 368 patients with diabetes mellitus. The next type of probability sampling is called systematic sampling. In systematic sampling, it involves selection of every case from the list. After randomly selecting a starting point, it could be every third person on the list, it could be every 10th person on the list, it could be every 15th person on the list. And this type of sampling technique requires less time and resources, but still ensures that the population member has the equal chance of being selected. Now, how does systematic sampling work? For example, if your population is 1,000 and you just need a sample of 100, in here what you can do is to divide 1,000 by 100, and that would mean 10. So you pick every 10th person after randomly choosing a starting number from 1 to 0. As simple as that. Now, systematic sampling is easier and quicker than simple random sampling. However, the problem with systematic random sampling is that if there's a pattern in the population, for example, every 10th person has the same shift, it could probably introduce bias. Okay, I'll give you a specific example. A hospital roster lists all nurses alphabetically, and you wanted to select every fifth name to participate in your study on nurses' stress. That is systematic random sampling. Now, this is an example of a research conducted utilizing systematic random sampling. A study conducted on the incidence of failure to communicate vital information as patients progress through the perioperative process. From a population of 1,858 patient records in the healthcare system, the researchers selected every sixth case. Hence, this is a systematic random sampling. Now, the next type of probability sampling is called stratified sampling. This method is used when the population includes important subgroups, or we call this as strata, such as age, gender, ethnicity, religion, socioeconomic status, level of education, etc., depending on your research purpose. Now, how does stratified sampling work? In here, basically, what you do is you divide the population into strata or subgroup. And once they are divided into subgroups or strata, for example, age or for example, gender, then you randomly sample within each stratum based on its proportion in the population. And this is very important because this ensures all relevant groups are represented. Now, for you to be able to clearly understand how stratified sampling technique is done, I'm going to show you a clear example on the next slide. Okay, suppose you want to conduct research on stress at the university from first year to fourth year students. So basically you wanted to collect data from all students across different levels, and you wanted to use stratified sampling technique. The first step that you need to do is to identify the number of students in each level. And in our given example, we have 4,000 students across different levels. The next thing that you need to do is to identify the percentage of these students given the total number of students that we have. So, and here we can see that 50% are first year student. In here we can see that based on the number of students, second year is 25%, and the third year and fourth year is 15% and 10%. Now, after you have identified the number of the population based on strata, by the way, your strata here is year level. Your students are grouped according to subgroup, which is year level. Now, the next step that you need to do after identifying the number of population is to identify the required sample size. For example, out of 4,000 students, you just wanted to include 364. How does it work? It's very simple. Now, based on this calculation, you just need to take 50% of 364, and that would mean 182 students in first year. What is 25% of 364? That would mean 91 students. What is 15 and 10% of 364? That means 55 and 36 fourth-year students. So in here you can see that the number of the participants is stratified according to your level, and the percentage of the samples, or the number of samples, was basically calculated based on the proportion of these students in relation to the whole population. This is a good example of stratified sampling technique. Now, the fourth probability sampling technique is called cluster or multi-stage sampling. And this sampling technique is used for a large spread out population. Instead of sampling individuals, you sample groups or cluster first, then sample within them. I want you to look at the PowerPoint carefully. How does it work? First, randomly select cluster. Okay, for example, nursing schools or hospitals. And then your stage 2 is that within each selected cluster, you randomly select participants. And you can repeat the process through multiple stages, as you can see on the slides in here. And this method is more economical in terms of money and time than other sampling method. Now, cluster multi-stage sampling is cost-effective and practical, especially if you're planning to include a large population. However, the limitations of this sampling technique is that it can be complex to plan and may introduce cluster level bias if it is not done carefully. Now, for example, you want to study burnout or stress in nurses across country. The first stage was probably randomly selection of 5 regions or state. And the second stage is randomly selection of, for example, 5 hospitals per state. Okay? And the third stage would be randomly selection of nurses within each hospital, within that particular state. That is cluster multi-stage sampling. All of these methods involve random selection, which is very important in reducing bias and increase generalizability. And the best sampling method, because you may probably ask me which method is best, it depends on your research goals. It depends on your available resources. And it depends on the structure of your population. Okay, before we proceed with non-probability sampling, I have here a question for you to answer. Let's try this question. A nurse researcher identified a total of 500 patients with diabetes and wants to recruit participants through systematic sampling. Take note, the question is asking about systematic sampling. How should the nurse perform this method? A. Randomly select patients from the list of 50 patients with diabetes. B. Choose patients based on their age, selecting only those aged 40 to 50 from the list of 500 patients. C. Assign the number to each patient on the list and randomly select 50 numbers. Letter D. Select the first patient randomly from the list and then select every 10 patients thereafter until 50 patients are chosen. What do you think is the right answer? The correct answer is letter D. Select the first patient randomly from the list and then select every 10 patients thereafter until 50 patients are chosen. Now let's shift our focus to non-probability sampling. And as previously mentioned, when we talk about non-probability sampling, this is when participants are not randomly selected. In here, participants were selected based on judgment. Now, the first type of non-probability sampling is called convenience sampling. And this is considered as the most commonly used non-probability sampling. In here, you select participants who are easy to access or most readily accessible. It could be your classmates, it could be your coworkers, or it could be people nearby. And this type of sampling technique is used when researchers need to gather data quickly. What are the strengths of convenience sampling? Fast, easy, and inexpensive. However, the problem with convenience sampling, because participants were selected based on accessibility, there is a high risk of selection bias in here. Okay, let me give you an example. You want to study sleep quality among nursing students and decide to survey students from your own class because they're readily accessible and available. This is an example of convenience sampling. The second type of non-probability sampling is called quota sampling. Now, quota sampling is used when you want to ensure your sample includes certain proportions of key groups without using random selection. Okay, in here, your participants are selected based on predetermined quotas or proportion. Okay, and in here, you set quotas based on traits like age, gender, year level, or shift schedule, and then intentionally recruit participants to match those quotas. And using convenience sampling, participants are purposefully sampled to match this quota. Now, for example, you want 60% female and 40% male nursing student in your study on clinical stress. So basically in here, you recruit students until you meet those numbers, 60% female and 60% male. You already determined the proportion of female and male participants. The next type of non-probability sampling is called purposive sampling. In purposive sampling, you select people based on specific characteristics that are important to your research. In here, you're not looking for just anyone. You're looking for insightful participants. And this type of sampling technique used by setting a specific criteria. Now, for example, you want to explore coping strategies among nurses who work in COVID-19 ICU units. In here, you specifically chose ICU nurses with at least 1 year of experience during the pandemic. In here, you have set a specific criteria. First, ICU nurses during pandemic. That is purposive. You cannot just collect data from any nurses, from any wards. In this research, it is very specific ICU nurses during pandemic. And this type of research requires purposive sampling technique. Now let me give you a specific example of a research design in which a purposive sampling technique was used. Sharawi et al. 2021 assessed changes in objectively measured physical activity levels at 2 weeks and 6 weeks and reported cardiac self-efficacy at hospital discharge in patients recovering from AMI. A repeated measure design was used to recruit a purposive sample of patients from a single center in Jordan who were diagnosed with first myocardial infarction and who did not have access to cardiac rehabilitation. You might probably ask, why purposive sampling and what specific criteria has been used by the researcher? First, the patient should be diagnosed with first myocardial infarction. The second one, these patients should have not access to cardiac rehabilitation. These are specific criteria and hence purposive sampling was used. The next type of sampling technique under probability sampling is called network or snowballing. This method is helpful when you're studying hard to reach or hidden population or samples that are difficult or impossible to locate. For example, nurses with rare specialties, or it could be patients with stigmatized conditions. Now in here, you start by selecting a few participants using purposive sampling and then ask them to refer others they know who meet the criteria. In here, your sample snowballs from there. That's what's called network and snowballing. Now, let me give you a specific example. For example, you are researching mental health experiences of male nurses in rural areas. You begin with one or two known participants, and then you connect, and then this nurse or your sample will then connect you to others. It's an example of snowballing. Now, one of the important strengths of snowballing sampling is that this is great for hard-to-reach groups. However, the problem in here is that it can introduce network bias, where participants are similar to each other. Now, for final takeaway, non-probability sampling is often practical and useful, especially if you have a very short time to collect data, you have limited resources, and if you are dealing with specific population. However, it's very important to remember that these methods comes with limitation in terms of generalizability and bias. That's why it's very important that you are very transparent when you're reporting your sampling method in your research. Now, this is an example of a research which uses a network and snowballing sampling technique. Mujugira et al. In 2029 characterized HIV and STI risk prevention needs and sexual decision-making among trans men in Uganda. Data were collected from 50 trans men through snowballing sampling. They conducted qualitative interviews and asked several questions to explore sexual practices, their experiences, their perception of service delivery. And you would notice in here that the samples that are included possess characteristics that are hard to reach, or this group of populations might be hidden within the population, and these patients might have a stigmatized condition. That's why the researcher conducted a snowball or purposive sampling. Okay, just before we proceed with our next topic, let's try to answer this question. A researcher wants to conduct a study involving male nurses in the first year of work experience in the hospital. Which non-probability sampling design would be most appropriate for this research? A. Convenience sampling. B. Purposive sampling, quota sampling, and snowball sampling. The answer is purposive sampling, because in here you are selecting your respondent based on specific characteristic. First, male nurse. Second one, first year of work experience. Hence, the answer is purposive sampling. Now, we'll be talking about sample size. And most probably, many of you will be asking, how large should be the sample size in order for my research to be more generalizable and for my research to be valid and reliable? Now, a general rule is always to use the largest sample possible size. And the larger the sample size, the more representative of the population it is likely to be. Smaller sample size produce less accurate result. And the good thing is, there are formulas, there are available tools that could help us researcher to identify the sample size of our research. And we're going to discuss that in the next few slides. One of the most common formula that we use to determine the sample size in our research is called Slovin formula. In here, what you need to do is just to identify the total population size. For example, you have a population size of 5,000 patients, and you need to identify the margin of error. In most research, we utilize 5% margin of error, which means you are 95% confident that your research is valid and generalizable. And given the total population size that you have and given the margin of error that you have, by utilizing this formula, you can now identify the required sample size. In our given example, you are required to collect data from 370 patients. This is called Slovin formula, and we normally use this if our population is too big and we just wanted to reach out an adequate sample size for our research. In addition to the formula that I have presented, the good thing is that there are available tools online that we can use to determine the sample size for our research study. And personally, as a researcher myself, I would usually use the online calculator developed by Daniel Soper. And it is available online free, depending on the type of statistical analysis and the variables that you wanted to examine. Here you can use several types of calculator, and you can freely access this one through the link provided on the slides right now. Our next topic focuses on one of the most critical aspects of research: data collection methods. Whether you're conducting experimental or non-experimental research studies, the quality and credibility of your research findings heavily depend on how data is gathered. And before we start our discussion on data collection method, I'm going to share with you a classic case of poor data collection with very serious consequences. And in here, you can see the title of the book, The Doctor Who Fooled the World, Andrew Wakefield's War on Vaccine. In 1998, Dr. Andrew Wakefield published a research study suggesting a link between MMR vaccine and autism. Sounds alarming, right? The study used parental recall through interviews. And interviews introduces bias and inaccuracies. Parents were asked to remember events that occurred years ago, which most probably be unreliable. Eventually, his study was discredited, his medical license revoked, and the impact was very devastating. Why? Vaccine uptake dropped, measles outbreaks surged globally. And the case of Andrew Wakefield highlights the methodological responsibility of a researcher. Very simple. Our data collection methods must be valid and it should be appropriate for the research design. In the next part of our session, we're going to discuss the different data collection strategies and methods, and we're going to talk about which methods is most applicable depending on the research questions that you have. First, I would like to say that for all research data collection, it should be planned. And before selecting the right method, it is very essential for us researchers to reflect on several key components. First, what is your research question or hypothesis? You need to ask, what is the study purpose? Who is your target population? And what is the context? These questions are very important because it will guide you as a researcher in identifying which data is appropriate on your research and what data collection method is most applicable in your research. In quantitative research, there are 4 types of data collection methods: through observation, self-report, could be physiological, or it could be existing data. And we're going to discuss one by one this type of data collection method. Now let's begin with observation. When we talk about observation, and here the researcher watch and record behaviors in either natural or controlled setting. Now, this type of data collection method is very useful, especially if you're studying real-time nursing care, patient interaction, or teamworks in a clinical setting. For example, you're observing how nurses manage interruptions during medication administration. Here, basically, you use observation. Or you are conducting a research about patient-nurse communication. And here, observation is the most applicable method of data collection. When we talk about observation, there are three common ways in how you collect data. It could be field notes. Basically, these are summary of observation to record activities. And field notes normally provides rich and narrative details of observed events. It could be also anecdotes, which contain short descriptive um, summary of observation, specifically focusing on behavior of interest. Or it could be structured observation using checklist to assist in standardizing the observation documented. What are the pros and the cons of observation? Of course, one of the pros is that it captures natural, spontaneous behaviors. However, there are also some cons of observation. First, observer bias. You know, the nurse may act differently, or the patient, or your samples or participants may act differently if they know that they're being observed. We call it as observer bias. And the other one is that it can also raise potential ethical concern, especially if the participant doesn't want to be observed or watched. The second type of data collection method is called self-report. This approach necessitates subjects to provide feedback regarding their experience, behaviors, feelings, and attitude. Now, self-report is one of the most common data collection methods in nursing research, and it includes either interviews or questionnaires where participants report their feelings, experiences, and attitude. For example, using a structured questionnaire to measure stress in nursing students. It's an example of a self-report data collection. Or if you are administering a pain intensity scale to a post-op patient, in here the patient will self-report the pain that they're experiencing. Or if you are conducting interviews with caregivers of Alzheimer's disease to explore their emotional burden using questionnaire, then this is an example of self-report. For interviews, you can either formulate a set of open and close-ended questions, and the most common way of collecting self-report data is basically questionnaire with the use of pencil and paper instruments to gather data. This is also known in other literature as instruments, measures, scales, or tools. Now, what are the challenges when it comes to using self-report data collection method? First is social desirability bias. What do we mean by social desirability bias? In here, our participant may underreport symptoms or may underreport their experiences or may underreport their stress, for example, so that they will appear as competent and as healthy as possible. And that's very common in quantitative research. And the second one, since you might probably be using questionnaires, especially if it is lengthy, especially if the questionnaire that you are using is confusing, you might probably cause respondent burden. These are the two challenges that you might probably encounter with self-report. First, social desirability bias, and the second one is respondent burden. However, there are also other advantages of using self-report. First, this is inexpensive. And the second one, it's easy to administer to large samples. That's why many researchers utilize self-report, particularly interviews and questionnaire. Now, on the slides right now, you will see examples of questionnaires using closed and open-ended question. And these questions have been used in an actual research. While in this screen, you will see an example of a questionnaire in the form of a Likert scale. This is a standardized questionnaire used to screen depression. Now, in addition to observation and self-report as data collection method, there's also another method of collecting data in quantitative research. We call it as physiological methods. It involves the use of specialized equipment to determine the physical and biological status of subject. These are objective measures of biological functioning, especially useful, especially in studies that examines stress, pain, sleep, cardiovascular health, and etc. And when we talk about physiological methods, it could be physical, for example, temperature. Your research involves temperature taking. It could be chemical, especially if your research involves patients with diabetes and you wanted to measure your blood glucose. Or it could be microbiological, if your research includes accessing blood cultures, for example. Or if your research involves, utilization of radiological results, such as X-ray, for example, or CT scan. We call it as anatomical. Now, the good thing about using physiological methods is that there is high precision, which means your result is very precise and accurate, and it is less prone to reporting bias. However, the disadvantages of using physiological methods is that in most research equipment cost in complexity. That's why if your research involves physiological methods, it might require a huge amount of funding or grants for you to be able to acquire equipments. And of course, devices may influence behavior. Why? Because some patients might feel anxious, especially if some blood will be extracted from them, especially if they will undergo radiologic exam. It must somewhat affect, their psychological state. They will become anxious and therefore affecting the result. And the fourth data collection method is the use of existing data. In some other book, we call this secondary analysis. And in this type of data collection method, the researcher used data that has already been collected. For example, electronic health records. For example, government databases. Or for example, hospital quality reports. This data has already been collected. We call it as existing data. It could either be use of records or use of databases. Now, for example, if you wanted to analyze 5 years of hospital readmission data to study risk factors, why patients are being readmitted, you most probably used a data already been collected previously. Or, for example, you're trying to review nurses' notes to explore documentation trends on fall prevention. In here, you can utilize electronic health records, data that has already been collected previously. Or you wanted to use government databases, like, for example, the National Health Survey interview survey from CDC. These are available data that has been collected. These are existing data. And what are the pros and what are the cons of using existing data? First, it saves time and resources. Why? It has already been collected. Second one, it allows access to large, diverse sample size. Many of these data that has been collected contains a large amount of diverse samples. However, there are some cons when it comes to existing data. First, limited control over variables. In other words, some data might be missing. And the second one is there might probably be challenges when it comes to accessing and data sharing due to HIPAA or institutional policies. Hospitals might not freely share their data, and because of the HIPAA law, researchers might probably have issues in accessing this data. Okay, now let's try to do some exercises. On the slide, you will see 4 research questions, and the instruction is very simple. Given the research questions provided, determine the most appropriate data collection method. And the choices is outlined below. The first question is, what are the dietary habits of patients diagnosed with type 2 diabetes? What do you think is the best and the most appropriate data collection method? The second one is, what is the impact of music therapy on reducing anxiety levels and cortisol level in pediatric patients undergoing medical procedures? The third research question is, what is the prevalence of nosocomial infection in a specific hospital ward over the past year? And number 4, what are the communication patterns among nursing staff during patient handover in a critical care unit? I'm going to give you 1 minute to think about your answer. Is it self-report measure, observation, physiologic measurement, or existing data from records or database? Okay, here's the answer. For research question number 1, what are the dietary habits of patients diagnosed with type 2 diabetes? So basically in here you can use self-report using a questionnaire, or probably you can conduct interviews. For the second research question, what is the impact of music therapy on reducing anxiety levels and cortisol level in pediatric patients? Here, most probably you can still use questionnaire, but since it involves cortisol level, you might probably use physiologic methods or physiologic measurement. The third is, what is the prevalence of nosocomial infection in a specific hospital over past year? So in here we're looking for data collected already, so most probably we will be using existing data, such as records or database. The fourth one, what are the communication patterns among nursing staff during patient handover in a critical care unit? We're talking about communication patterns, so most probably the most appropriate data collection method is observation. Now that we have discussed how data is collected, let's move into how we analyze the data, specifically in quantitative research. Now, quantitative data analysis is the process of organizing numbers, identifying or summarizing patterns, and of course, drawing conclusion based on a statistical test. Now, when we talk about data analysis in quantitative research, it's not just about crunching numbers. It's about making sense of what those numbers tell us about the research problem. Now, let's try to look at some common types of statistical tests used in quantitative research. Take note, choosing the right test depends on the type of data that you have and the research question that you are asking. Now, the first type of statistical test is called descriptive statistics. If your goal is to summarize the data, you can use descriptive statistics. For example, you wanted to calculate the average or the mean stress or anxiety among third and fourth year students. In here, you might probably be using descriptive statistics. But if you want to compare whether there's statistically significant difference in stress between these groups, for example, third year versus fourth year, or male versus female students, in here you can use inferential tests like t-test. However, if you are comparing stress levels, for example, among 3 or more groups, let's say across all 4-year levels, first year, second year, third year, and fourth year, in here you're going to use ANOVA. Now, to test relationship between categorical variables, such as stress levels, categories such as low stress, moderate stress, high stress, And in relation to clinical shift type, for example, nurses in day shift or nurses in night shift, here you are using chi-square test. Or correlation is used when you are interested in relationships between two numeric variables. For example, you wanted to examine the relationship between stress and hours of sleep. Correlation analysis will tell you how strongly those two variables are related. We call it as correlation. And if you want to predict the student's stress levels using factors like GPA, clinical hours, and sleeps, in here you will use regression. In other words, understanding the right test will help you ensure that your research conclusions are valid and reliable. And the knowledge of the different statistical tests is very important as a nurse researcher. And you might probably be asking, is it very important that we know exactly how to run those tests? Having an understanding is also good. However, today, when you conduct research, normally a part of your team is a statistician who will help you analyze and make sense about those data or numbers that you have collected. These are the different types of statistical tests that you're going to use when analyzing data in quantitative research. Okay, let's try this question. A researcher is interested in conducting a study to investigate the differences in post-traumatic stress levels among three distinct groups of individuals: veterans, active military personnel, and civilians. The question is, which statistical tool or test may be applied to analyze the data collected from the study? And here, you are interested to know the differences in post-traumatic stress, and in here you have three distinct groups: A, independent t-test; B, paired t-test; C, ANOVA; D, correlation. What do you think is the answer? The answer is ANOVA, because in here you are comparing more than two groups: the veterans, active military personnel, and civilians. And that's all for today. Thank you and good day.